Hi there, welcome to your lesson on surface area. Let's get started. Okay, we are still firmly in the area of geometric solids. Surface area is all about the area for all the surfaces around a 3D solid. So let's recap. We have talked about polyhedrons and curved solids, which are not polyhedrons. Here are polyhedrons are called prisms because they have two congruent parallel bases, and here are polyhedrons called pyramids. They only have one base instead of two. These are all polyhedrons because the faces are all polygons. Over here, we still have 3D solids, but they are not polyhedrons because the faces are not polygons. With those in mind, let's look at finding surface area of all of these. This is what this lesson's all about. What are the formulas for surface area of all of these? Okay. Oh, here's another good thing to look at. Hey, you maybe have heard the song, "It's a Small World After All." Well, Dwight says false. It is not a small world. The Earth's surface area is 148,940,000 square miles. Sounds like Dwight. All right, let's keep going. So the surface area is defined as the sum of the areas of all its faces. Pretty simple. You take a look at all the faces making a solid, you find the area of each face, and you add them up. That is your surface area. It is kind of like the outside or the skin of a shape, which is different than the volume. The volume was all about that space inside a shape. We've been looking at that. But now we're talking about the surface or the skin of the shape. So let's say we have this basic rectangular prism. Its net may look like this. Now the surface area can be found by considering the two bases, which are marked with the capital B here, and there's two bases here, and then the full lateral area, because you remember the faces along the side that are not the bases are called the lateral faces. So here we have all the lateral faces. So we can say the surface area would be the two base areas plus the area of four lateral rectangles. That makes sense. To find the entire surface, we're adding up all six faces. Here's a triangular prism. It's a triangular prism because we have one base that's a triangle, and congruent and opposite and parallel to that one, another base, the same triangle. So it's a prism with these two bases. Here's the net for that one. And notice the net has the two bases, and then it has three lateral faces, not four like the last one. This one had four. This one only has three, because there will always be the same number of lateral faces as sides on the base, because one lateral face grows from each side of the base, right? So here's that, but it's the same idea. To find the surface area, we take the area of the two bases plus the full lateral area. So the surface area would be the two base areas plus the area of three lateral rectangles. Now here we have a pyramid. Same process. Yes, a pyramid is not a prism, but it's still a polyhedron. It still has faces. If we can find the area of all the faces, we have the surface area. So here's the net for that one. We can see the square base and these four lateral triangles. So the surface area here would be one base area, not two anymore, just one, plus the area of the four lateral triangles. Okay, now let's talk about a cylinder. When you think of a cylinder or the surface area of a cylinder, I want you to think of this. Yes, I want you to think of toilet paper. Why? Because toilet paper is in the shape of a cylinder. But more than that, toilet paper helps us really visualize what happens when we unwrap a cylinder and make it a net. Because what we have is two bases. They are circles like this. And then you have this lateral surface, which, you know, when you unwrap a roll of toilet paper, that lateral surface is just a long rectangle. And that's all we have. When we wrap that lateral surface around a cylinder, it's just a long rectangle. So let's take a look at it like this. Here's our cylinder. Here's its net. We have the two bases, which are circles. And then we have this lateral surface that we unwrap, which unwraps into a rectangle. Now, the important thing with this is to understand what the length and width of that rectangle are. So this is our circle. And we know a circle has a distance around it, or perimeter, called a circumference, found by the formula 2 pi r. Where does that appear on this rectangle? Because when we unwrap this rectangle, that red line represents what part of this rectangle? Well, it is this part here. Just imagine that. Imagine rolling this around here. this length is the same as this circumference. So the length of that rectangle is actually 2 pi r. And what's the height? Well, the height of that one is the same as the height of the cylinder, right? So now we have two base areas, which are each circles, so pi r squared is the area, plus this rectangle. So the surface area of a cylinder is 2 circles, 2 times pi r squared, plus the lateral area, which is actually 2 pi r, because we know this is the circumference of this circle, times h. So this formula is really important to remember, and it's best if you really understand why it is what it is. So again, 2 circles plus the lateral area, which is this rectangle, which is 2 pi r times h. Great. With all of that, we can now move on to cones and spheres. So cones and spheres, we've talked about the volume, but now let's talk about the surface area. For a sphere, this is something interesting. Check it out. Here's a sphere, and how can we find the surface area? Now imagine this. If you took a piece of paper with this height equal to the diameter, so like this is your diameter. Imagine you had a piece of paper that had the same height as the diameter here, and the length of the paper was the same as the circumference of the sphere, then that piece of paper would wrap perfectly around the sphere. Imagine that, taking this and wrapping it around there. Yes, it would get kind of crinkled up if you were pressing it on a sphere, but there's exactly, this surface is exactly what the surface of the sphere is. It's kind of amazing to think about it that way. So now let's come up with the surface area formula. So if this rectangle represents the surface of the sphere, well, let's look at this rectangle. Rectangle begins as base times height, which I've written here. But this base here, we said, is actually the circumference of the circle, like if you wrapped around the sphere. So it's circumference times d here, because it's actually the diameter of this, right? So I've replaced b and h with circumference and diameter. And now circumference formula is 2 pi r. Diameter is actually 2 times radius. So to find the surface area of a sphere, we've begun with a rectangle, put in these circle formulas, and now we're down to this 4 pi r squared. Really amazing. Just think about it. It is amazing to think that this rectangle wraps perfectly around here, and therefore that's where the surface area of a sphere formula comes from. So that's what it is. All right. So make sure to note that one down, just as you've noted the surface area of a cylinder. Okay, those two students often forget, so make sure you note those. And now let's continue from there. So there's the surface of a sphere. And now let's finish off with a cone. So here we have two nice sketches of two cones. What is the surface area of a cone? Here is the formula. Write this one down as well. Surface area of a cone is found by doing pi rl, which is the radius, and the slant height, L, is actually this distance here. And we add pi r squared, which is the area of a circle. So this represents the base of the cone, whereas pi r l represents the lateral area, the area around here. Why does this work? Where does this formula come from? Let's take a look. I have a great diagram to show you where this comes from. So here's a cone, and here's the cone at the net of the cone. Okay, so here's the base, and here's the part that wraps around is the lateral area. Okay, imagine this part wrapping around here. So now let's do a little proof. Let's see if we can sketch this and figure this out as I go. So what we have here, this is the the slant height, and that appears right here. Okay, imagine this part again sits on the bottom of the circle, and this becomes the tip of the cone here. So that is the same. All right, next, this part here, the radius here is actually, where is that radius? Let me see. Sorry, this is our circumference here. And where does that appear on here? Well, that circumference is this part here, because again, that part will wrap around this circle here. So that is 2 pi r. Okay, let's keep going. If you completed this circle, this part here represents a portion of the full circle. So we know that the full circle's circumference would be 2 pi l, because this L is now a radius of this full circle. So that would be the full circumference, but we only have this part here, 2 pi r. So check this out. We need this area here to get the lateral area. What we do to find that area is we say 2 pi r over 2 pi l, because we're saying we have this red portion out of the full circle. So we're saying what portion is this of the full circle? It's kind of like what we did with sector area or arc length. So we have 2 pi r out of 2 pi l, the whole thing. And then we multiply that by pi l squared. So we're saying basically we have this portion of the circle, and now we're going to find the area of it. So we're going to multiply by pi l squared, which is the area of this full circle. All right, so a little bit tricky, but I hope you're following. And now that simplifies into this. Okay, I just put that pi l squared on top. And now we can cancel some things. These pi's cancel, these l's cancel, the slant heights, and we're left with, and the 2's cancel also, okay, the l, and we end up with this, pi r l. So that's the area here of this portion, which is actually the lateral part of this cone. So that's where that comes from in our formula. If we go back to our formula real quick, whoa, lots of stuff. Okay, we have just proven where this comes from. And if that was a little hard to follow, I understand. It's hard to do these things sometimes, but give it your best. Think about it, maybe watch it again. And now let's continue to a couple practice problems. Now that we have all our formulas, let's use them. Okay, so here's a pyramid. We need the total surface area of a rectangular based pyramid, and we're given some dimensions. So remember, to find the surface area, we just need the base area plus the 4 lateral triangles. And notice the triangles are different on this side and this side. Let's see if you can figure it out. Well, here we go. The base area is simple. It's a rectangle. 10 times 8. 10 times 8, that's the full rectangle. Great. Now we have these triangles. Well, what's the area? Let's see, ABE. So look at triangle ABE. E is on top here. We don't see it. That triangle has a base of 10 and a height of 12. So we do base times height divided by 2, area of a triangle. It's 60. And then we have another triangle, BCE. That's the one on the side here. So some students automatically assume that all the triangles are the same. The 4 triangles are the same around the outside. They're not. You can see this is 13, this is 12. So BCE has an area of 8 base times height, 13, divided by 2, and that area is 52. So now the total surface area is the base, 80, plus 2 of these triangles, because the triangle in the front and the back are the same. So 2 of those, plus 2 of the other ones, those are the 2 side triangles. And there we have the full surface area. Pause if you need to. Let's try another one. So now we need the surface area of this cone. You're going to use the formula that you wrote down a moment ago, which includes the base area and the lateral area. Let's try. And this 17, by the way, is the height. It's not the slant height, it's the height. Okay, there's our surface area of a cone formula. In that surface area formula, we do need the slant height. So maybe pause and calculate this slant height. What is it? Can you use Pythagorean theorem? Yes, you can. So here is, I didn't show the calculation, but that 17.7 is calculated by using Pythagorean theorem on this triangle. And then therefore the surface area is the base plus the lateral area, and it all adds up to this number here. Here's another one. A cone with this radius has a radius of 5, and it has a surface area of 300. So in this case, you're given the surface area. So it wants you to work backwards with the formula we just saw, and it wants you to find the slant height. Try that first. Okay, so here's the cone drawn. Here's the surface area formula for a cone. We begin by putting 300 into it because we are given the surface area. And we fill in everything else. We know the radius. And when you write that formula in full, all you're left with is L. That's your only unknown. So you solve backwards for L, and you should get this. Okay, so one thing you could do is 300 minus 25 pi here, and then divided by 5 pi. That's how you get to that. Okay, and then the second question said, well, find the height of the cone. Well, now that you know the slant height, you can find the height because you know the radius, the slant height. You have this right triangle. You can use Pythagorean theorem to find h, and here's the setup for that. Hopefully, you got the same answer. I think there's one more question to try. Try this one. Find the surface area of this hemisphere, which means half of a sphere. Well, a few moments ago, you did write down the surface area formula for a sphere. So now you have a hemisphere, which is just half of that. So try it out. Here we go. Surface area of a sphere is that, but we have a hemisphere, so I'm dividing by 2. So we have this, put in the numbers you know, and you get this surface area. Great. Plus, oh, don't forget, when you have a hemisphere, don't forget, you also need the base, and the base is a circle. So we're going to find the area of that circle, add it together, we get this surface area. I hope that worked out for you. You can do it. These problems are not so bad. It's just about using a bunch of formulas and being able to visualize shapes. Great job.